আমরা মিক্সড পার্সেল ডেরিভেটিভ স্টার্ট করেছি, তাই তো? সোয়ার্স থিওরাম, ইয়ংস থিওরাম, এদের স্টেটমেন্টটা আমরা এবং এদের অ্যাপ্লিকেশনও বোধহয় করিয়েছি, দু একখানা করিয়ে ফেলেছি অলরেডি। বাকিটা আজকে কন্টিনিউ করা যাক। তো সোয়ার্স থিওরামের কন্ডিশনটা কি ছিল, মানে সোয়ার্স থিওরামটা কি ছিল সেটা একটু রিকল করে নিই। সোয়ার্স থিওরাম কি ছিল না, এফ একখানা ফাংশন ছিল, আর ডোমেন ডি সাবসেট R2 থেকে আর এ ফাংশন, রাইট? আর এ বি একখানা ডোমেনের ভেতরেরই পয়েন্ট, অবভিয়াসলি এ বি একটা ডোমেনের পয়েন্ট। এবার সেখানে দুরকম ভাবে ডিফাইন করা যায়। একটা হচ্ছে ধরো এফ ওয়াই যে পার্সিয়াল ডেরিভেটিভ, এফ ওয়াই অ্যাট এফ এক্স, এফ ওয়াই এক্স ওয়াই আর কি, এফ ওয়াই যে ফাংশনটা, দ্যাট ইজ এটা এক্সিস্ট করবে, এক্সিস্ট ইন সাম নেইবারহুড অফ এ বি, এ বির কোনো একটা নেইবারহুডের মধ্যে এটা এক্সিস্ট করবে। আর সেকেন্ড কন্ডিশন হচ্ছে এফ ওয়াই এক্স ওয়াই যেটা আর কি, এই যে জিনিসটা এটা কন্টিনিউয়াস হবে, ইজ কন্টিনিউয়াস অ্যাট এ বি পয়েন্টে কন্টিনিউয়াস হবে। যদি হয় তাহলে দেন স্টেটমেন্ট বলছে যে তাহলে এই এর উল্টোটা, দ্যাট ইজ এফ এক্স ওয়াই যেটি এটা হয় আর কি, এটা এক্সিস্ট করবে অ্যাট এ বিতে, এক্সিস্ট at ab, and এই যে মিক্সড পার্সিয়াল ডেরিভেটিভ f of xy at ab, f of yx at ab, they are equal. এটি অ্যাকচুয়ালি সোয়ার্স থিওরাম ছিল আমাদের, তাই তো? বেশ, আর মিক্সড পার্সিয়াল ডেরিভেটিভের ফর্মুলাগুলো কি রিকল করতে হবে, একবার করে নিচ্ছি। ধরো fx at ab, ফর্মুলা কি, x যখন থাকবে তখন লিমিট h টেন্ডস টু 0, তাই তো? তাহলে f of এদিকে a প্লাস h, b মাইনাস এফ অফ এ বি বাই এইচ। এখানে একটা কথা বলি, ইফ এক্সিস্ট, যদি এক্সিস্ট করে তবে আমি ইকুয়াল টু দিয়ে সিম্বলাইজ করতে পারি আর কি। আর একটা ছিল এফ ওয়াই অ্যাট এ বি, ওয়াই যখন হবে তখন কি ছিল, লিমিট কে টেন্ডস টু 0, এফ অফ এ বি প্লাস কে মাইনাস এফ অফ এ বি বাই কে দিয়ে ডিফাইন করেছিলাম যদি এক্সিস্ট করে। একই রকম ভাবে এখান থেকে আমরা মিক্সড পার্সেল গুলো করেছিলাম, তাই তো? আগের ভিডিওতে সবটাই রয়েছে, ফর্মুলা ডিটেলস এভরিথিং, রাইট? তো এখন আমরা নেক্সট প্রবলেমে চলে যাচ্ছি। আমি দুটো প্রবলেম করিয়েছিলাম আগের ক্লাসে, দেখলাম। নেক্সট তাহলে থার্ড প্রবলেমের দিকে আমি একটু মুভ করছি। সো দ্য থার্ড প্রবলেম ইজ দ্যাট fx ফাংশন ডিফাইন করা আছে, দেখো লেট f of x y, this is equals to xy when mod x greater than is equals to mod y, and minus xy when mod x less than mod y. The question is that so that fxy at 0 0, fyx at 0 0, they are equal. Okay, sorry, not equal, they are not equal. সাথে আরো একটা কোশ্চেন আছে, হুইচ কন্ডিশন অফ সোয়ার্স থিওরেম are not satisfied by f. Okay, which conditions of Schwarz theorem are not satisfied by f? আচ্ছা, ফার্স্টে মিক্সড পার্সিয়াল ডেরিভেটিভ গুলো আমরা বের করে ফেলি, কেমন? আগে এটা বের করে রাখ, চলো। তো এগুলো বের করতে গেলে ফার্স্টে কি করতে হয়, দুটো at 0 0 তে বের করে নাও ফার্স্ট অর্ডার পার্সিয়াল ডেরিভেটিভ গুলো, দ্যাট ইজ fx at 0 0 লাগবে। সো দিস ইজ লিমিট h tends to 0, f of 0 plus h comma 0 minus f of 0 0 by h if exist, যদি এক্সিস্ট করে তবেই কিন্তু। সো লিমিট h tends to 0, f of h0 minus f of 0 0 by h if exist। ঠিক আছে, এবার দেখো এই জায়গাটাতে এখন আমার কি আছে, এইখানে দেখো h আর k কম্পোনেন্টটা 0, দ্যাট ইজ y কম্পোনেন্টটা 0, তুমি সেই এখানে বসাও আর এখানে বসাও, যেটাই বসাও না কেন 0ই দেবে, তাই না, কারণ এই k কম্পোনেন্টটা তো 0 এখানে। সো দিস ইজ লিমিট h tends to 0, দিস ইজ 0 minus 0, তাই না, 0 minus 0 by h if exist। This implies limit h tends to 0 over 0, that is 0। আবার fy at 0 0 টাও বের করে এগুলো সব কাজে লাগবে তো, তাই না, এটা মানে কি লিমিট k tends to 0 f of 0 0 plus k minus f of 0 0 by k if exist, if exist। ঠিক আছে, একই রকম কনসেপ্ট, দেখো এগুলো তো আলাদা কিছু নয়, এখানেও তাই একই ব্যাপার ঘটছে। দেখো লিমিট k tends to 0, this is f of 0 k minus f of 0 0 divided by k if exist। okay, now this is limit k tends to 0, একই কনসেপ্ট। এই জায়গাটাতে দেখো এই যে x কম্পোনেন্টে 0 হয়ে গেছে, ফলে মাল্টিপ্লাই হয়ে যাবে তো আলটিমেটলি 0 হয়ে যাচ্ছে, 0 minus 0 0 তে 0 হচ্ছে বাই k হয়ে গেল। so this is limit k tends to 0 over 0, that is 0। এবার দেখো আমি যদি f of x y at 0 0 বের করতে চাই তাহলে সেক্ষেত্রে কি হবে, এই জিনিসটা কিভাবে শিখেছিলাম, এই জিনিসটা বলছিলাম যে ডেল ডেল x টা বাইরে থাকলো, এটা হচ্ছে তোমার fy at 0 0 এর গল্প আছে এখানে। এবার তাহলে ডেল ডেল x মানে কি, তাহলে এইটা হচ্ছে h tends to 0 হয়ে যাচ্ছে, আর এখানে ফাংশনটা অ্যাকচুয়ালি f ফাংশনটা fy এর কাজ করছে, fy টা f এর ফাংশন, fy টা f এর কাজ করে দিচ্ছে, রাইট। সো তাহলে fy h তো তার মানে 0 plus h, 0 minus fy 0 0 by h, তাহলে এই জিনিসটা আবার ক্যালকুলেট করতে হবে, দ্যাট ইজ fy h0, fy h0 এটা লাগবে আমাদের। সো নাও fy h0 টা একটু ক্যালকুলেট করে নাও, fy h0 এটাকে বা হ্যাঁ ক্যালকুলেট করে নাও, আলাদা করে ক্যালকুলেট করতে পারো, নাহলে সরাসরিও বসিয়ে দিতে পারো, বুঝতে পারছো, fy h0 that is limit k tends to 0 y এর জন্য, তাহলে এটা কত হবে f of h আর এদিকে 0 plus k, that is a k, আর এটা হচ্ছে f of 0 h0 by k if exist, if exist। আচ্ছা, এইবার এইখানে একটা গুরুত্বপূর্ণ বিষয় তোমাকে মাথায় রাখতে হবে, একটা ইম্পর্টেন্ট ফ্যাক্ট, যে ফাংশনের ডেফিনেশন একটু ভালো করে খেয়াল করে দেখি, এটা বোধহয় xy আছে when mod x টা greater than equals to mod y, আর এটা মাইনাস xy আছে when mod x less than mod y। আমি তবুও একবার দেখে নিচ্ছি ফাংশনটা ঠিকঠাক আমি চিনলাম কিনা, হ্যাঁ ঠিকই আছে। এবার দেখো এইখানটাতে অ্যাকচুয়ালি k tends to 0, তাই না, তো k tends to 0, এখানে h টা তাহলে k টা ফিক্সড, তাহলে k টা কি হচ্ছে tends to 0 তে চলে যাচ্ছে, তাহলে এই কন্ডিশন স্যাটিসফাই করবে নাকি এই কন্ডিশন স্যাটিসফাই করবে। দেখো এই যদি ফিক্সড হয় তাহলে mod h ভ্যালুটা কিন্তু পজিটিভ ভ্যালু এবং একটা ফিক্সড পজিটিভ ভ্যালু। এবারে যদি কিনা k tends to 0 হয়, k tends to 0 means y corresponding, তাহলে এটা কিন্তু স্যাটিসফাই করছে না, তাই না, এটা কিন্তু স্যাটিসফাই করছে না, তাহলে এটা নেগেটিভ হয়ে যাবে, যে মানে এইটা যেহেতু tends to 0 হয়ে যাচ্ছে তাহলে এর থেকে ছোট, বুঝতে পারলে কি বলছি, মড ভ্যালুটা সেটা স্যাটিসফাই করবে না, কিন্তু এইটা স্যাটিসফাই করছে, দেখো কারণ mod h greater than equals to mod k, এবারে k tends to যখন 0 হয়ে গেল তাহলে এই জিনিসটা কি হবে, 0 দিকে এগিয়ে যাচ্ছে, মানে ব্যাপারটা কিন্তু ট্রু, mod ভ্যালুটা কিন্তু greater than equals to 0, mod ভ্যালুটা greater than equals to 0, বুঝতে পারলে। বেশ, তাহলে এখানে খেয়াল করতে হবে যে এই জায়গার জন্য আমার ডেফিনেশন হবে কোনটা, প্রথমেরটা, দ্যাট ইজ hk হলো এদিকে, আর এটা তো 0ই হবে, এটা বাই k হয়ে গেল if exist। so limit k tends to 0 এখানে কে কে ক্যান্সেল আউট করে দেবো আমি, এটা ওভার এইচ হয়ে যাবে। সিন্স কে টেন্ডস টু 0 ইমপ্লাইজ কে নট ইকুয়ালস টু 0। ঠিক আছে, এইখানে আরেকটা, এই জায়গাটা একটু লজিকটা দেবে, আমি এখানে এই জায়গাটাতে লজিকটা দিয়ে রাখবে যে সিন্স এইচ ইজ ফিক্সড, এইচ ইজ fixed and k tends to 0, so therefore mod h greater than or greater than equals to doesn't matter mod k। এই কন্ডিশন হচ্ছে, তাহলে এই কন্ডিশন হচ্ছে, বুঝতে পারলে? তার জন্য আমি কিন্তু এই ডেফিনেশনটা ইউজ করেছি, এইটার কারণে এই ডেফিনেশনটা আমি ইউজ করেছি, পাশে বলতে হবে দ্যাট ইজ h। এইবার আমি f of x y at 0 0 টা ক্যালকুলেট করে দেখি তো, দ্যাট ইজ লিমিট h টেন্ডস টু 0, f y এদিকে কত আসবে, f y 0 আর এদিকে হচ্ছে h টেন্ডস টু 0, তো তাহলে 0 0 h 0 হবে, f y h 0 minus f y 0 0 by h if exist, if exist। এবার দেখো লিমিট h টেন্ডস টু 0, একটু আগে ভ্যালু বেরিয়েছে, এটা কত h বেরিয়েছে, সো দিস ইজ h আর এটা তো 0 বাই h, সো দিস ইজ লিমিট h টেন্ডস টু 0 ওভার 1 সিন্স h টেন্ডস টু 0 implies h not is equals to 0, তাই আমি উপর নিচে ক্যান্সেল করলাম and this is actually 1। আর একটা ক্যালকুলেট করতে হবে মিক্সড পার্সিয়াল, তার জন্য fx 0k না, হ্যাঁ fx 0k টা ক্যালকুলেট করে নিতে হবে না, fx 0k this is limit x মানে হচ্ছে h tends to 0, f of h মানে তাহলে 0 প্লাস h আর কে দিকে k minus f of 0k by h if exist, if exist, so this is equals to limit h tends to 0, it will be f of hk minus f of 0k by h if exist। So this is h, actually h। Now see, again we have to write this definition f of hk, here h tends to 0, h tends to 0, so what is the definition here? If h tends to 0, see, if h tends to 0 then k is fixed, k is fixed, that is the second definition, h tends to 0 means that tends to 0, and if k is fixed then mod k greater than 0, okay, so you have to use the second definition, that is minus xy, so limit h tends to 0, it is minus xy means minus hk, that is 0 by h, so limit h tends to 0 minus k, since h tends to 0 does not imply h is equals to 0, and since k is fixed and h tends to 0, so mod h less than mod k, right, that is just minus k, so therefore f of yx at 0 0 limit k tends to 0 fx 0k minus fx 0 0 by k if exist, this is equals to limit k tends to 0 and this is actually 0, okay, because y component x component is 0 here, so 0 and this value you got it 0 by k, limit k tends to 0 over 0, so this is 0. What happened? The first one is 1, second one is no, there is a mistake. Yes, f of fx0k, fx0k you got minus k, na? Yes, sorry, fx0k, this is minus k, this is my mistake, it is minus k actually, minus k, that is minus 1, since k tends to 0 implies k not is equals to 0, that means yes, this is minus 1. So first one is 1, I think I got, yes, first one is 1 and second one is minus 1. So if xy at 0 0 not is equals to fyx at 0 0, if xy and fyx they are not equal at 0 0. This is the first part of this given problem. Now come to the second portion. Is that the which condition of Schwarz theorem are not satisfied by f? See the Schwarz theorem, condition of Schwarz theorem. It was, yes. You can write in this way also. If you write if x, or if you consider fx, x partial derivative with respect to x, it is also true, and it will be if xy, if xy. Okay, this is another form of Schwarz theorem. You can take this or this, and this one or this one. And we change also, this is fyx at xy. Okay, okay. Now see, yeah, fyx and xy. Okay, and let's come to the second part. Second part. See, I got actually I got when 1 minute, when xy not is equals to 0 0, when xy not equals to 0 0, fxy, is it uh, that is partial derivative, that means del 2f del x del y. Okay, that means del x del f del y. At first calculate differentiate f with respect to y partially, then with respect to x, right? See the function actually, if function is xy when mod x greater than equals to mod y, and minus xy when mod x less than mod y, right? We got if xy at 0 0, we got it. See, this was just 1, yes, if xy at 0 0, this was just 1, but at 0 0, okay, we calculate this at 0 0. But see, when xy not is equals to 0 0, you have to find it. It is very simple. How? Just differentiate with respect to x and y partially. See, for this condition xy, so differentiate with respect to y first. If you differentiate with respect to y, it will be x just. Again with respect to x, that is 1 only. And see here, at first with respect to y, del y minus xy with respect to y means that is just minus x. Again with respect to x, this is minus 1. So it is just 1 when mod x greater than equals to mod y, and minus 1 when mod x less than mod y, right? Then when xy not equals to 0 0, xy not equals to 0 0, f of xy is 1 and minus 1 because of these two conditions. Okay, now see, we have to show that fyx or fxy is continuous at ab, right? Condition of Schwarz theorem is fxy continuous, fxy is continuous at ab. But I'll see that fxy is not continuous at ab. I'll see that fxy is not continuous at AB, that is at 0 0. For this, I shall move towards the origin along two different curve. Okay, if I move along two different curve towards the origin, and I will get to different value, I will get to different value because of this movement. That means the limit does not exist, and limit does not exist means if it's not continuous at 0 0. So see here, this is x-axis, this is y-axis. I am moving along x-axis towards the origin, moving along the x-axis towards the origin. Okay, and definitely which condition will satisfy? This is mod x greater than mod y. Okay, if you move along this x-axis towards the origin, that means mod x greater than mod y, because on x-axis y is 0, on x-axis y is 0. Understood? So mod x greater than 0, that is true, this is true, no problem, absolute value it is, right? And next I'll move along. Okay, first let me finish this. Let x y tends to 0 0 along x-axis, along x-axis, right? So therefore mod x greater than mod y, and because of that case, what will be the limit? Because of this case, the limit will be this, that is 1. So limit x y tends to 0 0 if xy this is equals to 1. And next, if I move along this y axis, that towards the origin, okay, towards the origin, that side, not this, from that side to that side, okay, that means here mod x less than mod y, and this is the second condition. Because of this on y-axis x is equals to 0, right? This is true, this is true, and this is the second condition, that is minus 1. Let xy tends to 0 0 along y-axis. So therefore mod x less than mod y. So limit xy tends to 0 0 f of xy, this is -1. So for different approach, different limits. That means limit doesn't exist. So therefore limit xy tends to 0 0, fxy xy, this does not exist. And limit doesn't exist means this is not continuous. So therefore fxy is not continuous at 0 0. This is the condition of, this is one condition. This is a condition of Schwarz theorem. This is a condition of Schwarz theorem. It does not satisfy. So therefore the condition of, oh, don't write this. This was the answer actually. Leave it. Stop it. You can write it. So the condition, this is the condition. This is the condition of Schwarz theorem. Schwarz theorem that is not satisfied by f. Okay. Next, come to next problem. Next problem is, let f of xy, this is x square plus y square into log of x square plus y square whenever x square plus y square not equals to 0. If it is 0, then function is 0. If it is 0, then function is 0. Now show that fxy, that is mixed partial derivatives, are equal at 0 0, and fyx at 0 0, they are equal. Although neither fxy nor fyx is continuous at 0 0. Okay, so see, proof. Okay, at first find the limits of the functions. At first find the partial derivatives, first order partial derivatives, fx at 0 0. Okay, what is the formula? This is limit h tends to 0, f of 0 plus h, 0 minus f of 0 0 divided by h, if exist. Limit h tends to 0, f of h 0 at 0 0 f by h. Now put the definition of this function f of h 0, that means h 0, so y component is 0, so this is h square log h square, that is 2 h square log h actually, and at 0 0 this is 0 by h. So this is limit h tends to 0 to h log h. Actually, this is basically yes. This is of the form. This is of the form log h divided by 1 by h. Okay. H plus, definitely h means h plus because of this log function. In negative axis log is not defined. Yeah, log function is like this, so that side negative axis log is not defined. So it was actually infinity by infinity form, infinity by infinity form, right? So you can have use this L-Hospital rule, definitely. L-Hospital rule, this is 2 times of limit h tends to 0 plus it is 1 by h minus of 1 by h square. It is actually 2 limit h tends to 0 plus minus h, that is 0. Similarly, see, look at the function. Actually, this is symmetric function. If you change x and y, you get the same format of this function again. So that's why in order to find out this fy at 0 0, it will be also 0. Similarly, okay, similarly it will be 0. Now you have to find again fx 0k, that is limit x means h tends to 0. It will be f of 0 plus h, 0 plus h, that is h, and k minus f of 0k by h if exists, if it exists. This is limit h tends to 0, f of hk. F of hk means it is actually h square k square log of h square k square minus f of 0k. It is 2k square log k. Same na? 0k, it is 0, that is x is equals to 0 and y is equals to k. Okay, so this is 2k square, sorry, k square log k square, that is 2 log k, and here k square, right? This is divided by h if exists. Okay, then this is actually 0 by 0 form, I think. This is 0 by 0 form. H tends to 0. Yes, it is 0 by 0 form. It is 0 by 0 form. If you put h is equals to 0, that is k square, to same it is h square, k square. It is 0 divided by 0 form. So use the L Hospital rule. Limit h tends to 0. It is actually derivative, that is h square k square divided by it. This is you have to define set with respect to h, understood? Because the limit on h, so it is 1 by h square plus k square is okay, but it will be 2h. Derivative of h square plus k square with respect to h partially, that is 2h, minus derivative with respect to h, it is actually 0, divided by h. No, this is 1, sorry, 1 by L Hospital, by L Hospital rule. Okay, cancel out. This is actually 0 again. Okay, so similarly, yes, similarly, that is also similarly if y is 0, it will be also 0. The same matter, same format. Okay, now come to mixed partial derivative, that is fxy at 0 0, limit h tends to 0, formula h, this is fy 0, no wait, h tends to 0, so it will be 0 plus h, 0 minus fy at 0 0 divided by h if exist, limit h tends to 0, fy is 0 minus fy at 0 0 divided by h. So limit h tends to 0, this is 0 minus this is 0 minus at 0 0, at 0 0 the value is 2, no 0, at 0 0 this is 0, this is also 0, so 0 minus 0 by h, limit h tends to 0 over 0, that is 0. Again, if yx at 0 0, y means it is k tends to 0 formula, fx at 0 0, oh no, this is not fx at 0 0, fx k 0, that is 0 0 plus k, so this is k minus fx at 0 0 by k if exist, if exist, limit k tends to 0, same 0 minus 0 by k, so limit k tends to 0 over 0, that is 0. So therefore both the mixed partial derivatives are equal, so if xy at 0 0 and if yx at 0 0 are equal. Now the mixed partial derivatives are now continuous at 0 0. Next, second part, the mixed partial derivatives, although they are not continuous, this and this both. Okay, so one of them is not continuous and similarly for the other. Okay, so that one of them is not continuous. Because of the continuity, we have to differentiate actually continuity of f of this at 0 0, right? Okay, f of xy, so you got f of xy at 0 0, but when xy not equals to 0 0, you have to find it obviously. Okay, because of this continuity, you have to find when x not y not equals to 0, xy not equals to 0, f of what is it, at first find f, okay, find f of xy. Okay, I want to show the continuity of check the continuity of f of xy. So first differentiate with respect to y partially and then with respect to x. Okay, so differentiate partially with respect to y, that is fy xy, fy xy. This is actually fy with respect to y, that is x square. What is the function? X square y square into log x square. This is the function actually, x square y square plus into log x square y square. Okay, so differentiate with respect to y. Okay, product from this is u into v rule. Y, that means 2y log of x square plus y square, and plus with respect to y means this is fixed, and this is 2y, actually 2y. See, when x square plus y square not equals to 0, and you got this is at 0 te, at 0 you got it is 0. That means it is x square plus y square is equals to 0. Again, f x y and 0, f x y, that is differential with respect to x again, with respect to x again. With respect to x means this is constant, that is 2y. Yes, it will be 4xy. Okay, 4xy. If you differentiate this is 2x divided by x square plus y square, right? With respect to x. So this is 4xy divided by x square plus y square. That's it only, right? And this is 0. Yes. When x square y square not equals to 0, and 0 if it is 0. Yes, you see this. Look at this function carefully. It is a homogeneous function. So just let us approaching the origin. Approaching the origin along the line y is equals to mx, where m is a parameter, right? So it is very simple. Just limit xy tends to 0 0 of fxy at xy. This is a limit x tends to 0, f of xy, that is 4 x, and y is equals to mx divided by x square plus m square x square. This is x tends to 0 for m divided by 1 plus m square. This is independent of limit. Okay, this is x tends to 0 when not equals to 0. This is independent of limit, so therefore this is 4m divided by 1 plus m square. It is in the form of parameter. See, this one varies because of this m, which is different for different values of m, which is different for different values of m. So therefore limit does not exist. So limit xy tends to 0 0 fxy, this does not exist. That means it is not continuous. Hence fxy is not continuous at 0 0. Okay, similarly you can see that fyx is not continuous at 0 0, right? This is another example which showing that the Schwarz theorem, condition of Schwarz theorem are not necessary. Okay, the inequality mixed partial derivative are equal, not equal. Sorry, mixed partial derivative are equal, but the converse is not true of Schwarz theorem. Okay, this example shows that actually the condition of Schwarz theorem can write it the condition of Schwarz theorem are not necessary for fxy at AB is equals to fyx at AB. Okay. So let's see one more example, one more problem here. F of xy, this is equals to x square tan inverse y by x minus y square tan inverse x by y when x not is equals to 0 and y not equals to 0 and 0 elsewhere, right? 0 elsewhere. So that if xy at 0 0 and this is equals to fyx at 0 0. Okay. So start with fx at 0 0. Use the formula limit h tends to 0 f of 0 plus h, that is h0 minus f of 0 0 by h if exist. Limit h tends to 0 f of h0, right? F of h0 okay. See elsewhere case, this is elsewhere case. If x not equals to 0 and y both are non-zero, x and y both are non-zero, then use this definition. Elsewhere means this equals to 0, this equals to 0, or x is equals to 0, y not equals to 0, or x not equals to 0, y is equals to 0. That. These three cases are there in elsewhere part, right? So it is 0 just, so it is 0 minus 0 divided by h. Limit h tends to 0 over 0, it is 0. Next fy at 0 0, that is k. Oh yes, it is similarly, so no need to calculate it again. It is 0. It's also 0, right? So now if xy at 0 0, that is limit h tends to 0. Okay, wait, I first calculate this one. fx 0 k, this is limit h tends to 0. F of 0 plus h, yeah, that is h k minus f of 0 k divided by h if exist. if exists. Limit h tends to 0 f of hk. Hk means see the definition. Yes, see the definition. This is x squared tan inverse y by x. This is h square tan inverse y, that is k by h minus k square tan inverse h by y divided by h, right, if exists. No, one more definition is here. Actually this value is 0. This is 0. It is elsewhere case. This is elsewhere case. Elsewhere case. It is 0. See the definition? Definition? Yeah, elsewhere case. This one case. H tends to 0 limit. Now this is a problem to calculate the limit directly. Yeah, h tends to 0 by h. Okay, see one thing. If h tends to 0, tan inverse k by h. H tends to 0, tan inverse k by h, or one thing. You can separate it. Yes, this is limit h square tan inverse k by h. Break it, and this is k square tan inverse h by k by h. It is limit h tends to 0. It is h. You can cut one h. Tan inverse k by h minus limit h tends to 0 k square tan inverse k square tan inverse h tends to 0, right? Okay, tan inverse h by k by h. You know this value is 0. You know this. I think you know this. This is 0. This limit is 0. All of you know that, right? But here it is h tends to 0. So tan by 0 is 0. Tan by 0 is 0. It is 0 by 0 form. Minus k is limit independent. So k square limit h tends to 0. Limit h tends to 0. And here tan inverse h by k by h. So it is 0 by 0 form. Use L hospital rule. Minus k square. Limit h tends to 0. Differential with respect to h. This is 1 down part, but upper part it is actually tan inverse. So this is at first 1 divided by 1 plus h square plus k square, and with respect to h, derivative of this with respect to h, that is 1 by k only. So this is minus k square limit h tends to 0. It is actually k divided by h square plus k square. if you put limit h tends to 0 here, so it is k cube by k square, so this is just minus k. See, it's just minus k, right? Okay, next, see, next one. So therefore mixed partial derivative of f of xy. No, another you can find it again, f of y is 0. This is limit k tends to 0, f of hk minus f of h0 divided by k if exists. This is limit k tends to 0. This is a definition of f of hk, that is h square tan inverse k by h minus k square tan inverse h by k, and this is 0 by k if exists. Limit k tends to 0, same way, this is h square tan inverse k by h by k, and minus limit k tends to 0, you can cut 1 k, so this is k tan inverse h by k. This is bounded in deleted neighborhood of 0, and this limit is 0. Limit of k, this is 0, and this function, second function, is bounded, so product limit is 0, sk mappa by sk mappa. So limit when it is k tends to 0, tan by 0 is 0, it is also 0 by 0 form, right? Yes, h square independent of limit tan inverse k by h by h, that's it, and this is minus 0, so this stands for 0 by 0 form. Apply the L'Hospital rule, that is h tends to h square k tends to 0, different set, this is 1 part is 1, so actually it is 1 plus k square by h square, and this is derivative with respect to k, so this is 1 by h square, this is h, limit k tends to 0, h divided by 1 plus h square plus k square, right? Yes, so it is just h, right? Now therefore mixed partial derivatives f x y at 0 0, so it is x, that is h tends to 0, f y, h means that is h 0 minus f y at 0 0 by h. Simple, just formula with sum, nothing else. If exists, limit h tends to 0, see this one, fy h0, why is it, yes, fy h0, you got it just right now. It is h minus 0, this is 0 by h, it is actually 1. Again, if yx at 0 0, that means it is y, so it is k tends to 0, and it is fx k shows it is 0k minus fx at 0 0 divided by k if exists limit k tends to 0. See, this is fx 0k, fx 0k, yes it is fx 0k. See, fx 0k, it is minus k. So minus k minus this is 0, it is 0 by k, so it is actually minus 1. So therefore fx at 0 0, this 1, and this is not equals to fy is minus 1 if yx at 0 0, right? So this was the mixed partial derivative actually.